All right. So how's the HICRAS homework is going? Everything is smooth, no issues, lots of issues. Okay, so if you have, most of the issues will come from the boundary conditions, like when you start run, it will tell you that you have a problem in a specific boundary condition. So what I do, I go delete the boundary condition and rebuild it back. And to be as I told you last time, you make it close to the boundary, outside the boundary, not that far and not that overlap with the boundary. So if you start to having issues, you delete it and you redo it back. So it will take few trials, but you will get there. This is, I believe, the most problem. The second problem that you will have is, I believe my simulation is 1 week period. Maybe it was January 1st up to January 7th, right? When you run your model, it might, when you run 7 days, your simulation will end up here, will not cover the whole floodplain. This is because my simulation is very detailed. I include different Manning coefficients, like every part of the area has different Manning coefficient. Manning coefficient control how is the water flow, how fast it flows. I include land cover maps. I include lots of things. I didn't want to use all of this. I just want to give you the concept. So what you will do is you will extend the simulation time. Like you run your simulation after the 7 days, like you keep your simulation until 14 days. And once you let HICRAS run 7 days after the day that of the flood, like you will say that the flood started at some point. So you ask HICRAS to run 7 days. So when he runs 7 days, he keep tracking the water until the 7 days ended here. But what we want to do, we want more days so that we can let the water in the downstream and track them until they flow out of our boundary. If you want to change this, you will go here where you made the run for your simulation, and it changed like from January 2020. That's what we have until 7. You make it 10 or 14 until you let the water get outside of your mesh. And I believe also maybe if you increase the computational interval time, the mapping output interval, if you keep them like this, I believe it might enhance the accuracy of your simulation, like the way that I did it here. Okay, so just to try these two, and I believe it might help a little bit, makes your model much more appealing. So the second thing that I want to talk about it today is the project. So I'm gonna send you this week the project description for our class. It will be based on the hazard maps that you developed. First, I'm gonna check the hazard maps that you guys developed, and if it looks good, we might use them for the project. If they do not look good, I might send you, every one of you, I will send you at the accurate hazard maps that I have, because it's a very detailed, it includes lots of parameters like land use, land cover, different Manning coefficients, because the Manning coefficients, every part of this area has different Manning coefficient, like, because here is like roads, so the road has like the pavement, and roads has different Manning coefficients from the forest, and different Manning coefficient from urban areas. So all of this affects how the water flows. So my maps will be much better, and I will send each one of you different hazard map. So let me write a few things. For example, we will have like 10-year, 25-year, 50-year, 100-year, 200-year. I have 10, so I have also 500-year and 750-year, and also 1,000. 1, 2, 3, 4, 5, 6, 7, 8. I might miss 2, but we will only have 7 students in this class. You also are willing to run the simulation, so we have 8. So maybe we are gonna work with the high return periods, like the 50, the 100, the 200, 500, 700, and 1,000 year. So we might use this higher return period. Every one of you will get different return period, and I will tell you why we are doing this. So I will send you the hazard map. And then also I will send you the fragility parameters that you have already in your homework to develop one fragility function for one archetype. So I will send you a table that has the fragility parameters for the 15 archetypes that we can use them to model community, okay? So right now you will have the hazard maps and also you will have the vulnerability functions. So what is missing? Hazard and vulnerability. What is the third component that is missing to do risk analysis? It's the exposure, right? You need a community to apply this. So the community will be this community. I will be sending you, and I believe I applied the data on homework 5. It's a shapefile, the one that they use is building points. So this will have detailed information about Lumberton. The building points, like it will has what is the number of the stories, the foundation type. So you will find them in a number. I'm gonna explain them later, but you will have detailed information about the buildings. And I will not let you to develop an algorithm to identify an archetype. So I will also tell you what is the archetype of each building. Is it archetype 1, 2, 3, 4, 5? And then we will develop a MATLAB code that assign a fragility corresponding to each archetype. So in the for loop, we'll make a condition like if this archetype 1, use these fragility parameters. If this archetype 2, use this fragility parameters. So what we will do step by step, and I believe that you guys did it in your homework, is that I'm gonna send you the hazard maps and send you the building points. You will do the extraction of the flood depths at each building point. So you will know what is the building archetype. Is it residential, commercial, or what building archetype 1, 2, 3, 4, 5? And you will know the flood depths at this building. Okay, so you will know two things. You will use these two to run a MATLAB code to identify a damage. Okay, so step by step, I'm gonna list them in a Word file so you don't forget. So you will have hazard, exposure, vulnerability, do some GIS work to identify the flood depths at each building, and then take the flood depths for each building in MATLAB. You read the shapefile, you run vulnerability function, and get damage in terms of losses and exceedance probability of each damage state. So right now we are done with risk analysis, like basic risk analysis without any mitigation. But each one of you will get different hazard map. So one of you will get 50-year hazard map, one of you will get 100, one of you will get 200, 500, every one of you will get different hazard map. So who will have the maximum losses? The 50-year or the 1,000-year? Like 1,000-year, right? Because 1,000-year flooding event is a huge event that happens once in 1,000-year, okay? So basically, you guys will check with each other how much losses you will got for the entire community in 50 years and the other one in 100 years. So to make sense, the guy who calculated the 50 years should have less losses than the 100-year, the 200, the 500-year. That's basics. And then you all will pass your results to each other to do one additional step. What is this step? Okay, let's talk insurance. Let's see how people, like, for example, if you have a car or if you have a house and you are paying flood insurance or you are paying wind insurance, how these guys tells you how much per year or how much per month you pay for insurance. So these guys basically, they run multiple simulations, like from 10-year, 50, 100, 2,000, 1,000. They will run like maybe 20 simulations, okay? And then they will have curve like this with the return period. And loss, okay? So let's put here 10, 25, 50, 100, 200. This is not equal, just like making them. Yes, like the spacing is not equal, but you can imagine 1,000, 10,000. I believe the maximum that they do in insurance industry is 10,000-year event. And you calculate losses for a specific building. So the loss for 10-year will be like a little bit, and 25 will be much more, 50 will be more, 100 will be much more, will be something like this. So you'll end up with like having a curve like that. But right now, I don't know how much I will pay for insurance, right? I want to know how much I will pay per year for my car insurance or for my flood insurance, how much I will pay per year. So they calculate what is called annual average loss. What is the annual average loss? It is the summation of the frequency multiplied by the loss corresponding to each frequency. So if we are talking about return period I from I equal to 1, like I equal 1 equal 10, 25. So frequency of I and loss of I. So the frequency is 1 over the return period because return period is 10, but the frequency is 1 in a 10 or 1 in a 50. So what they do, you calculate the losses that comes from the 10-year. So you will have 1 over 10 multiplied by the loss of 10-year event plus 1 over 50 multiplied by the loss that comes from the 50 plus 1 over 100 multiplied by the loss that comes from the 100 and so on. And as you include more return periods, this will be much more accurate. So what we do is we calculate an average loss, weighted average, based on each one of these. So the 10 will give you a small number, right? Like 1 over 10 will give you 0.1, but it will be multiplied by a very low amount of losses. The 1,000 will give you a very huge losses, but it will be multiplied by 1 over 10,000. So the contribution will be very low. So what we do like a weighted average based on the frequency. So we weight them based on their frequency. Yeah, you have a low amount of losses that comes from a very like frequency of a 10-year, but you have a huge amount of losses that happens in a 10-year. And then you will end up with having a number. And this number is very, very important for insurance industry, the average annual loss. And this is how you calculate your premium. But they add much more numbers. Like let's assume that you got a number of $2,000. Like let's assume this is a flood insurance and you get $2,000. This is what comes from the losses. You keep adding lots of things to this number. Like you add other risks, you add some like overheads, offices, you keep adding a bunch of numbers, like, and the people who sells the insurance, like they need to get like, if you sell this insurance to some people, so you get like sales, commission, a lot of stuff. So maybe this number end by double. But this is the core of the number. This is what is very important. So this number, after you add all the overheads, it will end up with like $4,000. This number is very difficult to get, but the other stuff is very easy because you know them, they are certain, but this number is uncertain. So that's what needs to run through all the models, hazard, exposure, vulnerability, risk, and do all the analysis and get this number. So this is very important. So that's what I'm asking you, is that once every one of you is done with the losses, you pass your results to your friend. Like every one of you will have all the results. And we need to run this. We need to develop a curve. Maybe we make it for the entire community. Like we will actually, Lumberton got an average loss maybe for a 500-year event in between like 100 million to 120 million. So you will do a one for the entire community in millions and see how's the entire community losses look for 10-year event, 25, 50. And then you do it for maybe 5 buildings of interest. Like you select 5 buildings randomly. Maybe you all choose the same 5 buildings. Not all of you, because it will be the same results. So it should be the same results. Every one of you will pick 5 random buildings and run the simulation and show me how this curve look like. Okay, so at this point, we only run basic damage and risk analysis for a community under a specific event that I gave you, like 150 or whatever. The second task is the mitigation. So I want you to run some mitigation analysis, and I will show you the code that does the mitigation. I also send you some hazard maps with mitigation. So we will have a bunch of different types of mitigations. So these mitigations will be, what if we used a flood barriers around the building? So I will ask you to run some MATLAB codes or to develop some MATLAB codes to tell me if we use, like, for example, you will find that you have around 2,000 building got flooded from your scenario, which is 500-year event, 2,000 building. You'll tell me if we applied a flood barrier around this building of a height 1 meter, it will save me this amount of losses. So what if it's a 0.8 meter, it will save me this amount of losses. So I will ask you to run number of simulation for the flood barrier, like 20 centimeters, 40, 60, 80, and 1 meter. And you tell me how much loss reduction that you will get from that. Also, you will be asked to, like, for example, if only not the entire 2,000 building do this, what if 20 and 50% of these buildings did it? If 20% will be this, 50% will be that. It will be very simple. It's just like the same code, but you are applying it for a different numbers of buildings, okay? This is one of the things. Also, we will include like, what if we studied the impact of flood duration? So how is the flood duration is gonna impact the amount of losses? Did you guys see the 3D surface? That each time has different loss. So if you cut a different flood duration, you will enter completely different. I will give you all the 3D functions that you will interpolate from. So what you will do is, rather than interpolating the flood loss at 24 hours, you will interpolate for 48 hours. So it's just, you will change the duration of the flooding, okay? So all this will happen within a MATLAB code. What else? Yeah, and also will give you, like, for example, and actually this is what happens when it comes to fragility. Like for fragility, if we do enhancement to our buildings, you are changing the fragility function of the building. Because what I'm talking about right now, what if we use the flood barrier? So what did we change? Did we do anything to the building? We didn't do anything to the building. What we change is the hazard index, right? So if we have a barrier of 1 meter, so you are basically making an if statement. You are not changing anything. You will make an if statement. If the flood depth is less than the barrier height, so the losses is 0. But if the flood depth is more than the barrier height, so you will basically use this flood depth, and because the barrier will be like useless, like there's no barrier, and then we will use the fragility function, right? But if you did enhancement to your building, what will happen? For example, if we are talking about wind, what if we used a hurricane clip between the roof and the walls? If you use 1, what if you use 2? What if you used, rather than 2 nails, you used 3 nails or 5 nails? If you use the tile shingles or asphalt shingles, every one, so you are changing completely different things. So you will have to redevelop the fragility. Same thing in flooding. What if we are assuming that the TV on a table? What if we put the TV mounted on the wall? We are assuming that the AC unit is rested on the ground. What if we pose the AC unit by 1 meter? Let's assume that the household have a 1 day of warning. What if they were able to elevate the electronics? So I'm not gonna tell, I'm gonna ask you to rerun fragility. I'm gonna give you another set of curves that you will use that has the mitigation impact embedded in that.
It's higher than
The barrier.
yeah, barrier. So is that
We will assume that the barrier is useless, like it's not working.
but the flood depth our building is difference between flood depth and the barrier height.
No, because all the water will jump in and float it because you have.
Not all of them. The difference.
Okay, let's assume. Okay. Let's assume that this is your building, okay? And you put this barrier around your building, right? And the water is at this level, okay? So there's no water here. What you are saying is if the water is here, so all this just amount will come here, right? No, this is not the case because the amount of water is here is massive. It's massive. It's not like you are having a small amount of water. This is a completely flooded city, river. So the river will start filling this. Like it will come until all of them make one surface because the water will always pouring in the low area. Like even if there is a lake, it will go very to the lake, and once it's flooded, it will go around. So it all will make as a surface. Actually, the question that it needs to be like asked, but this will complicate the whole problem. if you put a flood barrier around every building, so that the flood depths, rather than will be here, it will be going up because you are ending these places. So if we want our models to be accurate, rather than saying in our model that if I put a flood barrier, I make an if statement, if the water depth is less than the barrier height, it will be 0, but if it's more than the barrier height, it will be the exact amount of losses. I need to redevelop another hazard maps that takes into account what is the impact if I build a barrier around 10% of the buildings, because it will completely change the hazard map, but this will be a very difficult step. Also, one of the things that I want to mention when we develop these hazard maps, we didn't assume the existence of the building. Like the digital elevation map that I gave it to you, it just make the grounds. It doesn't take the buildings as a blocks. So if you want your model to be much more accurate, you need to burn the blocks inside the hazard maps. Like my hazard map is like this. So what I do, and this is the buildings, right? Let's show it here. On ArcGIS, yeah. Let's make a zoom in. Now let's go also to HICRAS. Let's remove all these hazard maps. Let's zoom in here. Okay, so I have a bunch of buildings here, like there's a building here, but I don't take like the digital elevation map doesn't take into account that there is a big building here, okay? And right now, the water will flow like there is no building. Like the building, like the best or the, what we call it, like the best way is the water will flow around the building. But what we did in our model, we assumed that there is a ground and the water just flowing, doesn't go around the building. Okay, but I believe I read some publication that said like accounting for the buildings as a closed box, like because the best that we can do is we will say that there's a box here and this box is a different elevation. But what would happen is this is not a solid box. Like they are buildings, they are not maybe waterproof, and the water will goes inside from the windows, from the doors. So they are just like there and the water is going in. So but if you look at it from a water flow perspective and how they impact the velocity, yeah, maybe because when the water get blocked, it will like it goes around, so the velocity get increased. When the velocity get increased, the momentum get increased, and they make like kind of forcing on building. So you don't have a static flooding; it's a static and dynamic component. So the problem is very complicated, but this is not the objective. The objective is that we need to learn losses and vulnerability. But if we want to go more advanced, you will find lots of advanced things that you can do. You can account for the velocity, you can account for the combined impact of flood depths, flood duration, flood velocity, lots of stuff, okay? But let's focus on what we are doing. So what I'm saying is you can try that you burn the building, and actually it's very easy. So I tried it before. You have a shapefile, right? And you have the number of stories of each building. So if we're saying that this building is a 2-story and each story is like 3 meters or 10 feet, so you have 20 feet. So what I do, I merge, I convert the feature file of the buildings to a raster file. And the raster, when you convert it to a raster in the function in ArcGIS, it will ask you, what is the pixel value that you want to give for each one of these? I will tell ArcGIS take the pixel value from the number of stories or from the building height. And it will give each block a value, like we'll have a pixel value that is the total height, okay? And then you merge this raster value of the buildings with the raster map of the topography together. And what will happen is at each building, it will be replaced with the building block that has the same raster value. So basically, if this is like the building here, it will remove what is here and put the new value of the building. Okay, and I think I have it somewhere here. Let's actually, I will show it. Hopefully I will find it. Map layers. Add existing rest layer. Don't think I have it now. Okay. Right, so I don't have it right now, but this is how I want to show it to you that how's the building will look like. But let me also tell you, let's assume that we have a building that has a size of 10 meter by 10 meter. If your mesh size is more than 10 meter by 10 meter, that your model will not feel the building. Because also you need a fine mesh that can feels the corner, that there is a change. Like, for example, if when you develop the mesh in the geometry and your mesh is something like this, your mesh doesn't feel that there's a building here because the calculation only happens at the corner of the mesh and everything here is average. So it doesn't feel what's actually going on here. So it's useless. So if you want to do it, you want to make sure that your mesh size is very, very small. And with large area, the one that we are dealing with, like you almost, I believe I did it like 30 feet by 30 feet, which is like how many meters? Like it's kind of like 30, it's 10 meters by 10 meter. Maybe it can work. I believe maybe 50 or 60. No, it can't. Because we cannot exceed 1 million mesh. If you exceed 1 million element, it will be like, it might crash while doing the, no, so this is just like a heads up about if we try to build the building model. So we will take it step by step in the project. So let's see what is the first step. I will give you or the hazard map, or you already developed the hazard map based on the return period that I sent to you, and then extracting the flood depths at each building. So let's see that. Okay, so let's assume that we already got our hazard map, this one, and let's get back the Google satellite base map. All right, so you already have the hazard maps, you already develop it, or I give it to you, and then you will take it to ArcGIS here. And then you will have your building points, like I will give you a shapefile called Lumberton building points. If I open this shapefile, you will find a bunch of data. And the most importantly, let me see, I don't think it's this flooded. Okay, so yeah, also one side note, the number of buildings in Lumberton is 20,000 buildings, but not all of them are flooded. So it doesn't make sense if you keep running a MATLAB code for almost 18,000 buildings that are not flooded or have a flooded 0 and get damages 0. So what we will do, everyone will have a different hazard map. So you will exclude the building that has 0 flood depths so that you don't run your MATLAB code for 20,000 building, and you will end up having like around 25,000 building, depends on the return period. Like the 10-year will have less building, the 100-year will have more, the 500-year will have much more. And then you exclude the building that has 0 flood depths and only use the building that has flood depths more than 0 measured from the ground. So how can I do that? So basically, let's assume, okay, an attribute table. Okay, let's assume that this is the buildings and I want to extract the flood depths at these buildings. Like this is the building file. So what I will do is I will go here to extract multi-values to points and make sure that I put the raster map here. This is for Hurricane Matthew. It's not a return period, but it's a very close to 500-year event. And I have Lumberton building points. I will put them here and I will call that depth. And I will make sure that this is measured from the ground elevation and it's in meter. And then I will say, okay. All right, so let me close this and reopen it. Actually, it's here. Let me close it first and reopen it. Open attribute table. Should have the name that I give it, like this one, depths meter, this one. So this is the flood depths that I have. You will find that some building doesn't have zeros, they have -999. So that means that these building are like it doesn't have flood depths. So it's not zero, but they are not originally exposed. So maybe it's in the floodplain, but it's a zero, but this one is not exposed to the flood. So what I do is I go to select by attribute, and here I put depths meter, the depths that I calculated, and only select, you can select the values that are less than zero, maybe less or equal less than zero, and then I will apply. So the values that are less than zero are almost 18,000 buildings. So I only like this one, it's a show selected records only. So switching, what I'm doing right now, I'm switching from all the records to only the selected records so that I can do specific operations on these records. And I replace the -99 with 0. So I click here and I do field calculator. And I will put 0. I believe you can do this in ArcGIS Pro, same thing. Like I show it to you how to do it, change the whole thing, and then I will put 0. Same thing like wind, if you have a wind speed hazard map, you overlay with the building and then you extract the whole thing. Okay, so right now I made these 0. So right now you are at the point is, why did I change them to 0? Because if you choose to run your MATLAB code over the 20,000 building, your MATLAB code can run because it has flood depths of 0, and 0 is embedded in the fragility. If you have 0 flood depths, that means 0 losses. But if you have negative, it will give you an error because it will tell you it doesn't have anything that match the negative. So the second thing is that if you want to do it, I can switch the selection to the buildings that has flood depths to 0. So if you click on this one, like this button, you will find what's called a switch selecting. So I switch selecting here. So what I did here, I switch it to the buildings that has flood depths more than or equal to 0. Okay. Or if you lost that, you can remove the selection and come back here and do select by attribute, and you select the attribute that has flood depths more than 0. Okay, it's 21,000 buildings. So these are the buildings of importance that are exposed to flooding. If you zoom on selected, zoom to the selected, right. So you'll find that all the selected buildings, the one are in blue, are within the flood plain, but the non-selected are still green. So these are the buildings that we want to run vulnerability analysis for them. So what I will do, I export the selected building in a specific shape file so that I use this file for my analysis. So what you will do here, you click on the same shape file that has the 20,000 building, and you click on data, export data, and you will only export the selected features, not all the features. So you will find here all features and selected features. So I export the selected features, and you name them a unique name like, okay, let's select the folder. Okay, let's make a new folder and name it class project. Class project. Yeah, okay, let's within class project make folder shape files. And let's name this shape file Lumberton flooded buildings points. And then I will say save, and then I will say export. I will take a second and I will say, okay, I only need these buildings here. So you will have these, you can open them. And right now, if I open the attribute table, yeah, so here you have only a shapefile that has 21,000 building here. Okay, so right now these are the only buildings that I'm gonna do operation on them because they are only the flooded buildings. So what I want to talk to you about right now, that we will need another measure, which is the water surface elevation at each building. So when you run your simulation in HECRAS, you get two maps, the flood depths map and the water surface elevation map, and I will tell you why right now. So the flood depths map give you the flood depths measured from the ground, right? But we have two archetypes that we like. So some of the archetypes that we have are on a slab-on-grade foundation. And for these archetypes, we calculate the flood depths measured from the versi-floor elevation. Actually, we calculate most, oh yeah, we have 13 archetype with flood depths measured from versi-floor elevation. Like for example, we have the versi-floor elevation of each building. Well, let's assume this is the slab and this is my building. And for example, usually for slab-on-grade foundation, this is the ground. Okay, and maybe there's a step or two. So the versi-floor elevation is around 1 feet from the ground because there's the slab and there's 1 or 2 step and there's the flooring and stuff. And then this is the FFE. And this is the ground elevation, okay? 1 feet makes difference when it comes to flood losses. So we do our calculation not based on the ground elevation. But when you export this hazard map from HECRAS, this one, like if I click here, all these values, like this maximum. Like all these values, 0.2, 0.49, 1, all these are measured from the train, the digital elevation map, which is the ground elevation. But what I'm interested in is the flood depths measured from the versi-floor elevation. So if you have flooding in your home and it's like this is the water elevation, or we call it the water surface elevation, like this, I'm interested in that, not this. Okay. So what we do, and actually that's what's the most important, is the water surface elevation at each building, not the flood depths at each building. So basically, I do the same thing. like you export the water surface elevation map like this one, WSE, water surface elevation, export it outside of HICRAS, or I will give it to you for your project, and extract the water surface elevation at each building. And what you will do next step, you will have in your ArcGIS a field here, not this, FFE, but make sure that you convert the units, because here it's in feet. So if you have your water surface elevation in meter, you either convert the water surface elevation to feet, or you convert this to meter and do the water surface elevation, okay? All right, so you will extract the water surface elevation at each building, and then you will make another field for the flood depth, and then you measure it from FFE. How? You will do water surface elevation minus FFE. If it's positive value, that's fine. If it's negative value, that means that the flood depth is lower than the FFE. So you exclude this point from the analysis. Maybe your flood is here. So what does it mean? Does it mean it's above the ground elevation, but it's still less than the FFE and the water didn't make it to the home? So this is very important. So this is true for all the archetypes except two archetypes. We have two archetypes in our model. Archetype 1 and 3. Archetype 1 and 3, they are special because they are on a crowd space foundation, something like this, and we assume that there is some components here. So when we do the flood risk analysis, we do it from the ground. So, and this is how I built the fragility. Like this is how I built the fragility. I assume that this is the 0, and this is how the water is going up. But for these buildings, there is nothing here. So I assume that my 0 is FFE. So here is the ground elevation, and here is the FFE, but how I built my fragility, they are built on this flood depth. Okay. So I tried actually, because this was like kind of confusing when we applied this into Encore, like a big software that has all the fragility and a bunch of people is using it. It's less, it's not convenient for some people to tell, okay, this is how is the rules for these 13 and there's 2 has rules. So what I did, I assumed that this is my 0 and anything below is negative. So you will have to have the flood depths in negative. So this is a way, like a kind of like approach to go around and make all of them having the same base where you measure the flood. Not some of them are measured from the ground elevation and some of them are measured from the FFE. It's the same thing. Okay. All right. So this is one thing to tell you about. So once you accounted for all the flood depths at each building, and also you have the archetype for each building, like I believe, let me open this one. Yeah, so I will send you something like this that has the F archetype for each one. So you'll find that some archetype is archetype 15. You will have archetype 1, 2, 3. So you will have lots of archetypes, okay, from 1 to 15. And also you will be able to calculate the flood depths measured from the ground elevation and the flood depths measured from the VersaFloor elevation, right? How? You will have the water surface elevation. So what I do, I calculate the building ground elevation and the water surface elevation and the VersaFloor elevation. I need to have these 3, like ground elevation, VersaFloor elevation, water surface elevation. If you have these 3 components, you can calculate the flood depths measured from the ground and the flood depths measured from the FFE, right? The VersaFloor elevation. Okay, how? You subtract FFE from water surface elevation, you get this water depth. Subtract the ground elevation from the water surface elevation, you get this flood depth. So you get these 2. Why I need these 2? Because I have 13 archetypes that are measured by this, and I have 2 archetypes that are measured by this one. right? So this is how I do it. The next step is to take this shape file to MATLAB code and read it and do a bunch of vulnerability analysis using the fragility. Same thing like what we did for wind. Let's see how we do it. Okay, so when I start to like do the MATLAB code to do the vulnerability analysis, I need to read everything because we have lots of things to read. We need to read the vulnerability functions, all the fragility parameters. We need to read how much does it cost each building, so to do loss analysis. So we need to know the losses. We need to know the replacement cost of each damaged state so that we can run the loss analysis if you remember. We need to read the hazard maps. We need to read the shape files. So we need to read lots of files. So let's see how we can do that. I'll just give an introduction and next time I'm gonna continue. And at this point, I will be giving you the project description and all the data so that you can start like later this week or early next week in your project, okay? All right, so let's get to the MATLAB code. But before going to the MATLAB code, I want to do something from last class, because this is data that we are gonna use here. Do you guys remember what we did last time? We developed the 3D flood fragility functions, right? So, and also we have 2D flood fragility function from another lecture. So we have 2D and 3D. So the output from the 2D was the fragility parameters, right? The lambda and XC for each damaged state. And if we have 5, so each building has 5 lambda and XC, and you will find them in the publication that I uploaded with the homework. Did you guys check it out? Paper. Okay, this is the fragility parameters, and I'm gonna give you an Excel sheet with these parameters, okay? This is for the 15 building archetypes for flooding for the 5 damaged states, and there's something special about archetype 1 and 3. What is it? That it has damage state 0, and that's because it has a crawler space foundation. So we assume that the damage that happened for any component in the crawler space, like AC, like ductworks or any things here, is damage state 0, insignificant damage. So they have these parameters. And then all of them are from damage, like damage state 1 to damage state 4. I'm gonna give you the Excel sheet of these parameters so that you can use them the way that you did with wind, right? So this is one thing. Okay, so this is for 2D fragilities. How about 3D fragilities? If you guys remember from the last time, we were able to develop a 3D surface for each damage state for each archetype. So how we read this surface. So I will be giving you an Excel sheet that has flood depths and flood duration and a bunch of numbers. If you guys remember, we had 100 flood depths and 100 flood duration. And then we developed the numbers so that we can develop a surface in the 3D for each flood depths and flood duration. We have a point, and then we connect all of them to do a surface, right? So I'm gonna give you this sheet that can develop this surface. So it will be something like this. Actually, if we open the MATLAB code here, and if you go, for example, where image. Flood depths duration loss. Yeah, this one. Okay, so you have here. Okay, I'm not gonna like go through the MATLAB code today. I'm just like lay out what data that we need, and I'm gonna send you to prepare yourself with this data, okay? So, like, if you guys remember from the last time, we have, for example, damage state 0 for archetype number, like flood depths, flood duration, and this is, I believe, was archetype number 3. And if we go to the data here, you will find damage state 0. It's a 2D from 1 to 50, depends on the number of simulation that I use. I believe last time we did 50 so that we can run the code very fast. 50 flood depths and 50 flood duration. But I believe the data that I'm gonna send to you is 100 by 100. So I increased the accuracy. So I take this for all the building archetypes. So let me open this. Folder. You will have, I will send you an Excel sheet that has like this. It's called F1 3D, means that it has all the information that you need to build a 3D vulnerability function for the building. So we'll have a bunch of numbers like these and bunch of Excel sheets. So Excel sheet number 1 has F1, which means archetype F1. And you can go like in a table to know what is F1. F1 is a residential building on a slab, on a crawl space foundation, 1 story, okay? DS0 means this numbers is only for damage state 0. 3D, it's a surface, okay? And this sheet is F1, damage state 1, F1, damage state 2, 3, 4, and then you will have, after 4, because we don't have damage state 5. The maximum that we have is 4 damage state. And also you have one last Excel sheet, F1 loss 3D. In this Excel sheet, you will have the loss surface of this archetype as a percentage. So basically you go with the flood depths and flood duration and you get, I'm not sure it's percentage or not, let's see, it has the absolute value. So if it's more than 1, so it's not a percent. Yeah, it's more than 1. So this has the absolute value. Like all the numbers, as the flood depths and the flood duration is getting increased, you will find that the number are getting increased. Like here, we are starting with losses $19, 27. I'm not sure. Maybe it's a percentage, but it's not point. It's like 45% or so. Let's see if it gets to 100. Yeah, it's percentage, but it is not 0.1 or 0.2. Hundreds mean 100%. Okay. So I believe it's something like this. And what you will do, you will use this to build a surface. So this is how the Excel sheets will look like for each archetype. So you'll have one for F1, F2, F3, up to F15. I'm gonna send you all this information. Okay, let's get back here. Yeah. And also I'm gonna send you same thing with that has like an Excel sheet like this that has EC. When you see EC, that means that I did a mitigation measure. It's called elevating components. So I did elevating components for 4 archetypes. So it's kind of the same archetype, but with mitigation. For example, if I'm talking 2D, and I have, this is the flood depths, and this is the loss. This is the original loss function, and this is the mitigated loss function. Okay, so I did some mitigation. For example, I elevated components. I did something to the building that get this loss function down. Okay, so I will send you some Excel sheet that has a name like regular name, and some of them will have AC, elevated components, or mitigated components, okay? So if in your project, I asked you to compare between how much losses that the buildings has without mitigation and how much losses that has with mitigation, you run this and subtract them and see how much difference in losses that you have, okay? All right. Okay, so here I was just reading what I have. I was reading the damage state log normal parameters. I was reading the flood depths, like for example, I'm using here, okay. Let's hear, I'm reading the 2D loss functions. Like, do you guys remember when we did, we are gonna do 2D and 3D. We need 2D to get the amount of flood losses that only comes from flood depths. We only need 3D if we want to investigate the impact of duration. If we don't have duration, so there is no need to use 3D. Okay, so this parameters that I just showed to you, it just give you damage. It doesn't give you losses, okay? If you want losses, you will need a curve that capture the amount of losses corresponding to each flood depths. So I already did that. I already have these curves. They are not fitted. We didn't do any log normal fragility for the loss function. We just keep them as it is. Okay. So what I did, I take the X values of the depths and the X values of the losses and have them in an Excel sheet for each archetype. So I have an Excel sheet. It's called building archetype 2D. Like if I go up there, let's open it. Where it is? Let me go to the file here. Yeah, it's here. Can you see? I have building archetype 2D and building archetype 2D elevated. What is the difference? The difference, 2D doesn't have mitigation. The 2D elevated has elevated components, like elevated the EC unit and a bunch of units. And if you want to know what components that has been elevated, I will send you a publication also in the same folder of the project that has the list of the components that has been elevated. And how much elevation that each component has, this table. All the elevation and the new elevation for the HVAC pipes, the EC unit, the heating unit, the refrigerator, whatever units that I choose to elevate them. They have a mean and standard deviation, and after elevation, they have a new mean and standard deviation of the new elevation, okay? So this is one thing. And if I opened one of them, let's navigate them. This one. So the first, they have multiple sheets, okay? So the 2D, when we talk about 2D, it has multiple sheets. The first sheet has the flood depth value for all the curves for archetype 1, 2, like 2, 3, 4, from -2 up to 10 meters. Why -2? Because I have two archetypes. You guys remember I told you that I adjusted my fragilities to be all of them starting from FFE, and anything below the FFE, I made it negative. So that's what I did here. It starts from -2 up to 10 meter, and with a step of 0.1 meter. Can you see negative 1.8, negative 1.87? So this is the first thing. And this is the damage state 0 for archetype 1. This is 2D, okay, not 3D. Archetype 1 has one column because it's only one curve, okay? So we have F1 archetype 1 damage state 0 2D. This is the fragility curve. And then you have archetype 2, 3, 4, 5, 6, 7, 8, up to 15. Is there any one of you confused between the 2D and 3D? So for 3D, each archetype has a separate Excel sheet. But for 2D, all the archetype has the same sheet. And each column represents an archetype because it's a curve, not a surface. So each column, it takes the X curves, the X values come from the depths, the Y values come from here. This is damage state 0. So we have a sheet that has 15 column for the 15 archetype for the value of damage state 0. And another sheet with 15 column for damage state 1, damage state 2, 3, 4. Okay. So we have the 5 damage state here. I just want to tell you why I did this, because it's a lots of data. If we are talking about 5 damage state for each archetype, we have 15 archetype, and we have another one for flood depths and flood duration. So it's a lots of data. We need to organize them in a way that we can recall them and automate them in our analysis. Okay, so this is how we did it. And also we have another one for the losses. Like I have another one that has like the depths, it has F1 loss function, F2, F3. So this, each one of you represent the loss function for each archetype. Okay, so I go back to the MATLAB code. So first thing, I read this to the Excel, and I read sheet number that is named loss 2D. So this basically give me what is the loss for 2D function. The second thing, I also get another one from the other sheet that has elevated to get the new loss function if we have elevation. And also I picked the sheet loss 2D. So the difference between this sheet and this sheet is that one has mitigation. The first one doesn't has mitigation. Okay. So if I run my analysis with this one, it will give me a losses of $100 million. But if we run with this one, it will give me a losses of $90 million. So I can subtract them and see that I saved $10 million in losses if I use this kind of mitigation. This one, I'm reading the same Excel sheet, but I'm only reading the depth values. Actually, I can delete this and generate flood depths from -2 to 10 meter with a spacing 0.01. So you either can take them from the sheet or you can develop them on your own. This one, I'm reading the fragility parameters to get the damage. So what I did is I calculated the flood losses. Let me get to the sheet. It was here. So here I have the fragility values in 2 ways. I have them in parameters, and I have them in XY values. You can use either of those. You know, if we are gonna use the parameters, you will have to write a code that has log normal CDF, and you build them. But here you just import this. You don't have, because I already take all the values and I substitute and I calculate them. So you get them as an XY values. So you don't have to regenerate them from the parameters. So you either use the Excel sheet or you either develop them using the log normal parameters. Okay, so I read also the parameters, and I believe I have them in an Excel sheet somewhere here. Fragility. Yeah, this one. Like if I open this sheet, it says it's open. Yeah, this one. So I have the parameters here. I will give you this sheet so that you don't have to write them from the paper. And then I define the number of archetypes and the number of damage states. Then I read the Excel sheet that has the depths and the duration. If you guys recall, when we did the depth duration relationship, we get 100 value of the depths and 100 value of the duration from 0 to 10 meter and from 0 to 300 hours, right? And we made them equally spacing with like 50 or 100, right? So we need the values of the 100 value. Like it's not 0, 1, 2 up to 100. It's like maybe 0, 5.6 hours. If you guys remember, when we divide 300 hours over like 50, it will give us a number. If we divide like 10 meter over 50, it gives you another number. So I have an Excel sheet. It's called depth duration 3D that takes these values. I think it's in the same. Here, if we go to the MATLAB code and you have depth. Yeah, this one, depth duration relationship. So I believe it only has like 2 columns. Like a column here that is the duration, like 0, 3 hours, 6 hours, and the depth is 0.1, 0.2 until you get to the 10 meter. And the second step is to organize the data. So I have, for 3D, I have lots of information. I have 5 surfaces for each archetype. So I created, first I read all the Excel sheets, all the sheets in each Excel folder. Like I have, for archetype 1, I have F1 3D, sorry, I have F1 3D. This is the sheet name. Sorry, this is the file name, and this is the sheet name. Sheet that had name F1 damage state 0, F1 damage state 1. So I read all the sheet in the same Excel file, and I named this F1 damage state 0, F1 damage state 1, 2, 3, and 4, and I did this for the 15 building archetypes. So if you look here, I did this archetype F1, F2, F3, until I go all the way down to all the 15 building archetype, and I read all the sheets for the 3D function. Then I take all that and put them in a 4D matrix. What is inside this 4D matrix? The 4D matrix will have flood depths, the x-axis, flood duration, the y-axis, the number of archetype, 1, 2, up to 15, the number of damage state 1 up to 5. So I stored all, like how many sheets? 15 archetype by 5 damage states, 5 by 15. It's like 75 sheets. So it will be inside one 4D matrix. It's called F3D fragility. So this matrix has all the numbers. I go interpolate these metrics by the amount of flood depths that this building is exposed to. Like, let's assume that I have a building that has a flood depth of 1 meter and a flood duration of 24 hours, and it's archetype 4, and we want to calculate damage state 0. So I go with the flood depths, the flood duration, and the number of archetype, and damage state 2, and I get what is the exceedance probability. But I want to store all this data here, so I need to write a bunch of stuff. So I want to put archetype 1 here, and 1, 2, 3, 4, 5 is the damage state, and store them one by one. So basically, I put blocks. Put this sheet and this vector. Put this sheet and this vector. So that's what I did here. I put sheet number like F1 damage state 0. I put it in 1, 1. Damage state 1. I put it in 1, 2. Damage state 2. Put it in 1, 3. And then I go to the next archetype. So I change 1, 2, 2. And same thing. And here I started from 2 to 5. Do you guys know why? Not from, I don't have from 1 to 5 anymore. Because archetype 1 has 5 damage state, but archetype 2 has 4 damage state. So 2, like 1 represent damage state 0 because there's no vector number 0. So we start with vector number 1. So 1, 2, 3, 4, 5, damage state 0, 1, 2, 3, 4. But here, 2 is damage state 1, 2, 3, 4. And then archetype 3, I start from 1 because archetype 1 and 3 are special and has damage state 0. So I do the same thing for all the 15 archetype, and right now I stored all my fragility data. Okay. Well, with this, I will stop here at line 174, and next time we will continue and see how we can use the rest of the code. I'm gonna upload all the files that you need. I just want you follow what I do each lecture. Okay. So the project is just to follow what I do step by step. If you stuck with something, just email me, come and meet me, and we will fix it. Sounds good? All right. Okay. See you guys next time.